Welcome back to Module 1. We're working on the on your owns, and this video will begin with 1.12. These can be found on page 21, and we're going to do 1.13 and 1.4, which are on page 25. All right, so 1.12, we're asked to tell how many significant figures are in these measurements. So we're looking at page 21 to find out how do we decide. Now, a digit within a number is considered to be a significant figure if it is a non-zero, or it is a zero that is between two significant figures, or it is a zero at the end of the number to the right of a decimal point. Is this a non-zero? Yes. Non-zero. Non-zero. Those are both, all three of those are significant. How about these zeros? This is between significant figures, and this one is to the right of a decimal point. So all five of these numbers or digits are significant digits, significant figures in this measurement. So the answer here is 5. All 5 of them are significant. Looking at letter B, we have 0.0060. Okay, so the only non-zero digit in this is the 6. None of these zeros are between this one, or this one, are between two significant figures, right? 6 is the only one that we found so far. And these are not zeros at the end of the number to the right of the decimal point. This one, however, is a 0 at the end of the number to the right of the decimal point, and therefore it is significant. So there are two significant figures here. Looking at letter C, 1.00450 liters. Okay, all the non-zeros are significant. The zeros between significant figures are significant, and zeros at the end of the number to the right of the decimal place are significant. So all of these numbers are significant. 1, 2, 3, 4, 5, 6 significant figures. Okay. Letter D is 61.054 kilograms. Significant, 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 significant. This one is between significant figures. Therefore, all of these figures, all 5, are significant. Significant figures, significant digits. You'll hear differently depending on the text you're using or the course you're using, but the rules are pretty much the same. This is how we're going to find them. Okay, looking at 1.13. On page 25. Now we have to convert these numbers into scientific notation. Okay, so letter A, 26,789,000. All right, so scientific notation tells us what? How do we know how to make numbers scientific notation? We're going to have only one number, okay, to the left of our decimal point, right? So we're going to write it like this, 2.6789. These zeros are not significant because they do not occur between two significant digits or figures, and they are not at the end of the number to the right of the decimal. They're at the end of the number, and there is no decimal. It would be here. Decimal understood would be there. So they're to the left of the decimal. So they're not significant, so I don't need to include them in my scientific notation. How many decimal places did I get rid of? 1, 2, 3, 4, 5, 6, 7. 7. Okay, so 2.6789 times 10 to the 7th is the scientific notation for 26,789,000. Let's look at letter B. Letter B is 123. Okay, so all of the digits in 123 are significant. And to write it in scientific notation, we're going to write one number to the left of the decimal, and the other numbers to the right of the decimal. And then we include to the power of 10, and this is going to be 10 squared. 10 to the second power, 1, 2 decimal places. Okay, letter C, lots of decimal places. 1, 2, 3, 4, 4 zeros, and 9, 8, 7, 0. Okay, these zeros are all insignificant, okay? Certainly they have to do with the value of the number. We can't ignore them in terms of place value and those kinds of things. But in terms of reporting for science, they're insignificant. And so we're going to use these as our significant, these 4. All right, 9.87, and this 0 is significant because it's to the right of the decimal point, excuse me. So how many places did I move the decimal point? I moved it 1, 2, 3, 4 times 10 to the -5th. Okay? And letter D is 0.980. Okay, which are the significant digits? These 3. So we're going to write 9.80 times 10 to the -1. Okay, now we're going to look at 1.14, also found on page 25, and we're going to convert these numbers from scientific notation to decimal form. So 14a, 3.456 times 10 to the 14th. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 decimal places, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So 1, 2, 3, 2, 3. So that's 345 trillion, 600 billion. Whoa, big number. Okay, letter B. We're converting 1.2341 times 10 to the 3rd. That goes 1, 2, 3. So it's going to be 1,234.1. Okay, letter C, 3.45 times 10 to the -5th. Okay, so I'm going to need some room for some decimals here. 2, 3, 4, 5. 5, -5th, good. So 0.0000345. Hundreds, thousands, 10 thousandths, 100 thousandths, millions, 10 millions. 345 10 millionths would be another way to say that decimal. Okay, and letter D, 3.1 times 10 to the -1. Move the decimal once this way, we get 0.31. Okay. And that is it for this video. Hope you enjoyed.